Okay. A typical AP thing to do is to ask you to interpret computer output, which basically means they've found, there are various statistical software that will find you all the facts you need to know about a regression line. And these include facts you need to know for this course, facts you don't need to know for this course, facts you need to know in this chapter, facts that you probably will never use, all sorts of stuff. And you're supposed to be able to interpret the parts you need. And I'm going to go over the parts you need. I'll sort of sum up vaguely the parts you don't need and tell you what to throw out entirely. But they will ask you to interpret what some software package will give you when you ask it to create a regression line. So this is from an AP question where they asked about wind generating wind turbines generating electricity. So it's like how many megawatts relates to how many, and they were using, and they were going to use the speed of the wind to try to predict how much electricity was going to be produced. So the equation they have in mind is electricity produced equals A plus B times wind velocity. And they're asking you to take what they have printed out here and interpret it so that you'll know how to build the regression line. In other words, when you write y equals A plus B times x, they want you to be able to tell them what the coefficients A and B are based off of this printout, and also to understand what all the rest of this is. So the main place you want to look is the coefficients. The coefficients, the constant coefficient and the wind velocity coefficient. COEF will stand for coefficient. It'll be like the first row of something that looks like this. But it'll generally say coefficients or just C for both constant and wind velocity, and whatever the x variable, the explanatory variable is. So using this, I would say, well, if you want to predict how much power is going to be generated, take 0.137 megawatts or whatever, gigawatts, and then add to it 0.24 whatever watts for every amount of wind velocity. They're probably measured in miles per hour. And there you have your least squares regression line. So you're supposed to be able to read a printout like this, something generated by a computer, or in this case on the AP people, and interpret it. And it'll look something like this in each case. Now you might be wondering what all the rest of this means. I'm going to start with the stuff down here. Oh look, it's r squared. Guess how you can figure out r from it? Square root r squared. So r squared adjusted is not something we will be using in this course, but it has to do with other stuff. Overfitting. And S is the average size of the residuals. By that, what I really want to say is the standard deviation of the residuals. In other words, some points miss above, some points miss below. Some points miss by a lot above or below, some points miss by a little above or below. So the standard deviation of the residuals is the typical distance from the mean. And the mean residual is 0, because you have above and you have below. The mean is 0. And so by finding the standard deviation, the standard distance from the line, you can think of S as standard distance from the line. So averagely, it's like how much you expect to miss by. Well, my prediction for how much power you're going to get today is blah, but I figure we're probably going to miss the truth by about blah, by about S. So that's what that is for. Standard deviation of the residuals, or if you prefer, standard size of the residuals. Yeah, but they'll probably want standard deviation of the residuals, but use that in context. Okay, as for the rest of this, you won't need this till chapter 12. To summarize, you know, if you have like 20 points that you're trying to use to build your regression line, your regression line probably isn't exactly the correct regression line for perfect prediction. And standard error is how much how much your coefficients are probably wrong from the true reality by. But all of this stuff is going to be unnecessary until chapter 12, and you're not going to even know what a t distribution is until chapter like 10 or 11. So none of that is anything you have to worry about on the AP exam. There will probably be one question that involves something over here on the AP exam, and we'll get to that when we talk about chapter 12 briefly. And that's it.